All right, today we're going to be designing and building a mobile crane for HVAC work. So if you ever had to remove a compressor out of a condenser unit, you can use one of these lifting devices, but it's still pretty heavy to lift out of a condenser. Or if you need to lift equipment or heavy tools up through the roof hatch, like so, you can end up hurting your back trying to accomplish that. That's a problem we're trying to solve for by building this crane. Yes, you can buy cranes on the open market, but they're rather expensive. So using Autodesk Fusion, I created this 3D model, and I started with this sort of davit arm crane like this. You can see some of the main features of it. But the issue with this was it's still going to be expensive to buy all this steel, that hydraulic ram. So I thought, okay, let's do sort of a mobile gantry crane made of steel, electric hoist. Should the I-beam have a slight overhang? And I thought about maybe how about doing a cable winch? It goes up and down, but not side to side like this one. But again, the cost of steel these days is expensive. I do like this design, so I minimized the design as far as I could, and still the cost of the steel was going to be expensive. And this one can adjust up and down. Obviously, it can roll around. You can move the trolley and the hoist side to side. Plug it into a regular 120 volt outlet. You can see the power cord. Then I went with this guy, but it takes up too much headroom by using this style of electric hoist. So that wouldn't really work. So I even did an AutoCAD drawing of it. With adjustable legs, it might be able to compensate for the headroom. You can see it's got casters. Here's a trolley I was going to spec for this project from Vever.com. Not a paid promotion, just a good price that I found. It's adjustable side to side. Here's the electric hoist I was talking about, again from Vever.com. 120 bucks, ain't bad. And here's the casters that come as a set. 1,000-pound capacity per wheel, so that's plenty. What I ended up settling on, more cost-effective design, was to make it out of some pressure-treated lumber, some exterior wood. Now, we're not lifting anything super heavy, a couple 100 pounds at the most, so I feel comfortable making it out of wood. And we can hang that electric hoist from an lifting eye. So we'll just take a look around this design. You can see we have heavy-duty gussets at the base, as well as up top where the header plate attaches to the 4x4 posts. And that's to help prevent any racking or side-to-side movement. Again, my first choice would have been to weld it out of steel like you saw previously, but just the cost was going to be too expensive. So the wood was much cheaper. But again, obviously pressure-treated exterior lumber because it's going to be used outside. So here's the AutoCAD drawing I come up with. It's a multi-view drawing. You can basically see the lifting eye nut. A grade 8 bolt goes through that top header. You got a 1/4 inch thick steel plate, and then your grade 8 bolt head sits on top of that plate. And it's a laminated 2x6 top beam that'll be glued and bolted together. So we're going to start out by identifying, marking all our materials, cutting all of our wood pieces out. 3/4 inch plywood for the gussets. Just going to measure and use a straight edge here to make my marks for those gussets. And again, the gussets add structural rigidity to the overall frame of this crane. So all I really have to work with here on this project in our shop is a circular saw and a cordless drill driver. So you make the best with what you got. Obviously, it'd be nice if we had a little table saw or a radial arm saw, etc. But it is what it is. I'm trying to remember the cost of all the lumber for this project. It wasn't that much. It was maybe $100, $200. I purchased everything at Lowe's, ordered it online, had it delivered, I believe, or I picked it up. Can't remember. Okay, we got our first gusset cut. I'm just going to use that as my template to cut the other 3 gussets that I need. Now those bottom gussets are all cut to size. When you do these top gussets, and those will attach the 4x4 posts or the legs to that top header beam. There's those, all 4, 2 for each side. Now we can cut our 4x4 pressure treated legs. I'm just going to measure and mark, and I'm using clamps to secure the wood to my workbench so I can cut it safely. Anytime you use power tools, you want to wear proper PPE. I'm also going to cut the 2 bottom feet, horizontal feet. I'm going to cut that top header. Again, they're 2x6s. And unfortunately, one thing I noticed with the lumber that the Lowe's employee picked out for us is they weren't perfectly straight and true. They had slight warp to them. I'm going to use some wood glue or this wood adhesive. And these long hex bolts, washers, lock nuts to bolt everything together. So this is the top, again, the top beam, top header beam. And the reason I have to sandwich this 1/2 inch piece of plywood between the 2x6s is so we get the proper thickness to match the 4x4. That's what that's for there. So you can kind of see how the boards are slightly warped and not perfectly flat or straight, kind of bowed or twisted. I think I can take some of that out when I glue it and screw it together and bolt it together. I'm just trying to get everything lined up before I do my final assembly here. And while the glue is drying between the boards, I'm going to drive these countersink wood screws in. Okay, it's had a chance to dry, so the next day you can see how this is going to hang. There's our lifting eye nut that screws onto the grade 8 bolt, like so. And I'm going to use some Loctite on those threads. So we're going to drill our hole through the center for that grade 8 bolt to slide through. See that hole there? Let me know in the comments what you think about this design, or if there's something that you would have done differently. And that big square metal plate is just for safety, right? So we don't ask the wood to take all the weight of the load. It's going to be spread out over that metal plate and then spread out over the wood. And tighten everything down. There you go. Now I'm just kind of seeing how I'm going to do my gussets. See, the wood still has a little bit of a twist to it, unfortunately, but we'll make it work. This video was filmed in 2026, and the cost of lumber and the quality of lumber has been a bit of a concern, at least where I live. It's hard to find good quality lumber. And there's the hardware we're using. It's going to be through bolted. So it's wood glued, wood screwed, and through bolted. And so all the mating surfaces have wood glue between them. And I'm using exterior countersink wooden deck screws. Hold everything together while the glue dries. And there, the legs are done. Next, move on to rough assembly. See everything fits together and how level and plumb it is. And once I've got it pretty much square, I'm going to go ahead and lift it up, make sure it doesn't hit anything. And again, double check it for square and plumb and level. So checking vertically and horizontally. Looks pretty good, so I'm going to drive screws in to hold my adjustment. I think that'll work. Woo! All right, so now I'm going to go ahead and put some exterior paint all over the entire gantry crane. And this can be only rated for 500-pound capacity. So now I'm going to go ahead and drill all my through holes so we can attach our hex bolts and our lock nuts and washers. And just use a ratchet and a wrench to tighten everything down securely. Don't want to go too nuts and crack and damage the wood, but you also want them nice and snug, obviously. And I did 2 thick coats of this white exterior paint. The color was just something that we had in the shop, so we didn't have to spend additional money and buy more paint. We had what we used on hand, or we used what we had on hand, excuse me. And I painted that lifting eye or nut red. And so now I'm drilling my through holes, and then we'll bolt the legs and the top header beam together. Everything looks good, so we'll disassemble it and take it up onto the roof. Okay, now on the side of the building, we're lifting everything up as individual pieces through the roof hatch. All right, so now we're basically going to repeat the same process that we did in the shop, bolt everything together. I did the initial assembly in the shop just to make sure everything fit together and make it quicker and easier on site up here on the roof. Make sure everything's level and square and plumb. So I'm just going to tighten down all my nuts and bolts. Next, we'll go ahead and install the casters. These are heavy duty casters. They also have brakes and they swivel, so that's nice. And because we're drilling into wood, I'm going to pre-drill my holes before I drive in my lag bolts, because I don't want to risk splitting the wood, obviously. These are galvanized coated lag bolts. Let's test it out. It rolls nicely. Nice and sturdy. Looks good. Woo! Now we need to move on to do a load test. So we're going to do 125% of the maximum capacity for 15 minutes. We'll keep this load test certificate on hand, on file. And that's the final result. I hope you found this video helpful. And then of course we'll do an inspection before each use. And now I'd like to tell you about a practical facilities maintenance handbook available now in ebook and paperback format. It has common facilities documents, tags, signage, resource and training material, as well as common shop equipment drawings that you can use to fabricate shop equipment for your facility. The link for this book is in the video description below. Or if you need hats, shirts, mugs, or weather-resistant stickers for your facility, there is a link in the video description below for this online facilities maintenance store where you can purchase the products that you see here. I hope you find this helpful. Please like, share, subscribe, leave me a comment, and thanks for watching.